Hello everyone, in this video I will show you how to make an acetone lamp. For this experiment we will obviously need acetone. Open the bottle and pour in just enough to cover the bottom of the flask. Now we need some copper wire. Mine has a diameter of 1 mm, but any other would work just fine. Cut off the required length and wrap a coil around a glass stir rod, or a pencil. Bend the loose end of the wire into a hook, which will let us hang the coil on the neck of our flask. Now we can light our butane torch and start heating our coil. No need to get it red hot, as it can easily melt and fall off. Now we can lower the coil into the flask and hang it on the neck. The black oxide layer immediately disappears and the coil starts glowing red with heat. Now turn off the lights and admire the lamp. The coil remains hot due to the heat released from the reaction of the catalytic oxidation of acetone. Acetone oxidizes to acetaldehyde, producing carbon dioxide and water. Some of the acetone oxidizes to acetic acid, once again producing CO2 and water. Some sources claim that the acetone oxidizes to acetaldehyde and acetic acid in one reaction, without producing CO2 or water. I couldn't really check this, so I'll assume that both reactions are correct. Other sources claim that the reaction taking place produces toxic ketene gas and methane. However, this reaction isn't catalytic and it isn't oxidation. It is the pyrolysis of acetone vapors. Pyrolysis doesn't release heat and is carried out in an oxygen-free environment, which doesn't match our case. It is of course possible that a small amount of ketene is produced, but due to its instability, it instantly dimerizes into less toxic diketene or reacts with the moisture in the air, forming acetic acid. The best way to prove that copper serves as a catalyst by the principle of intermediate compounds is to throw some hot copper oxide into acetone. The acetone reduces copper from its oxide, forming an orange copper powder. Hence, the catalytic oxidation of acetone can be written in two steps. The copper is first oxidized and then reduced by acetone. If we are to stick to the version where no CO2 is produced, this can be written in a similar fashion. You can bend the copper wire in any way you want and experiment with some shapes. Wait, hold up, these aren't the shapes I meant. Here, how about a heart? If the shape is too big, acetone vapors will not reach far enough and the wire will stop glowing. And anyway, if your imagination is limited, you can just crumple together a bunch of copper wire. You can also bend the wire in the shape of letters. Sometimes the wire can fade and then start glowing again. By the way, the coil of wire can be heated over an alcohol burner. And if even that isn't available, you can use an ordinary lighter. Coins plated with either copper or brass can also serve as a source of light. The 2-pence coin is made out of copper-plated steel, which suits our needs quite well. You can see red waves on the surface of a coin. Acetone vapors first cool the surface, then oxidize on it, once again heating it. The 10 ruble coin is made from brass-plated steel. It works just as well. At times you can see a rainbow on the surface of a coin. The 10 kopeck coin is also made from steel and is plated with tombak, a type of brass with a high copper content. This coin can also be used. By the time I finished filming, I had plenty of broken off, oxidized and shiny coils along with a few colorful coins decorated by hot temperatures. Some coils and shapes also ended up being multicolored. The 10 ruble coin turned out to be the best, being partially colored blue and violet. I sure doubt I'll be using this as currency again. The other coin didn't really impress me. The 2-pence coin took on a violet hue, the copper surface cracked. That's all for this video, thanks for watching. Leave a like if you enjoyed this video and subscribe to my channel. Goodbye.